So far we've been dealing with remainder theorem and the sums based on remainder theorem. In this video we will be discussing the partner to the remainder theorem called as factor theorem. Now understand, this isn't really a different theorem by itself, it's actually just a special case in the remainder theorem itself. So let's see the statement first. When a polynomial f of x is divided by x minus a, the remainder is equal to f of a. And if the remainder f of a is equal to 0, then x minus a is said to be a factor of the polynomial f of x. Well, as you can see in the statement again, the first sentence here itself is just the remainder theorem all over again. And what it is telling us is that if the value of the remainder is equal to 0, the divisor is just a factor of the given polynomial. It's as straightforward as that. So remember, if you're dividing anything and if you get the remainder as 0, that's obviously just the factor, and so that is the factor theorem in itself. Like for example, if I have a situation like this, like x plus 1 is x plus 1 and the polynomial that is divisor is x plus 1 and the polynomial is 2x cubed plus 5x squared minus 11x minus 14. So again, x plus 1 is a factor, so that means if I equate the divisor x plus 1 to 0, so if I say x plus 1 is equal to 0, I get the value of x as minus 1. And when we find the remainder, right, as we do in the remainder theorem, the remainder, which is, if you guys remember, will be f of minus 1 in this case, right? And this remainder, because the said divisor is a factor, will be equal to 0. That's all that there is to the factor theorem. In the next few videos, we will solve a few sums dealing with this idea where if anything is mentioned as a factor, we just have to consider the remainder as 0. That's about it. Let's move on then.